never seen a graph before, but you know what? Graphs tend to show us some really, really neat trends. So I kind of dug this up and I kind of threw it on a spreadsheet. I thought this would be just awesome to look at. Look at what we've got here. Here's the term numbers. Okay, and again, notice that I don't start at 0. I can't start at 0 because there's no such thing as a 0 term. It's got to be starting, remember, as a natural number, a counting number, starting at 1. Okay, here's the Tn. I'm going to start at 100, then go down. And look how I'm going down. And I plotted every single one of these on the graph just over here. Okay, so now let's start interpreting the graph. Question here, the first question that it asks, is this sequence increasing or decreasing? Well, now that it's on the graph, I mean, it's pretty easy to see that this looks like it's going down. So in fact, it is decreasing. Now, it also asks you, down in this question right here, oh, there we go, what is the slope then? Well, first off, let's figure out the slope. Remember, slope is rise over the run. Okay, so let me just write that out, rise over the run. So I'm going to pick 2 points. Here's a point here. Here's a point here. My rise here looks like I'm going down minus 20 from my run here of 1. So my slope is a rise of minus 20 over 1. So my slope is actually minus 20. Now, what does that represent? Take a look at your table of values. If you look at your table of values, look how this is going from 100 down to 80, 80 down to 60, 60 down to 40. Have you figured it out yet? I have. This is your common difference. There's your minus 20. Common difference every single time. So your slope, in fact, is your common difference. So if you look at this in terms of y equals to mx plus b, guess what? Y equals to minus 20x plus something. Well, what is the b term? Well, you can't figure out the b term, at least not yet, because of the simple fact that, guess what? That would mean you'd have to have a term of 0. B refers to the y-intercept. We know it's 120. That's going to be our number, but wait a second. How can you prove that? How can you prove that that's actually going to be 120? Aha! So slope represents the common difference d, but what's the general formula? I'm going to tell you right now the general formula, Tn equals going to be minus 20x or n plus 120. That's going to be my general formula. I bet you that's what it's going to be. Now, let's actually prove this using our original formula, which is Tn equals T1 plus n minus 1 times d. Let's pick a number. Let's pick any 2 numbers, okay? So let's pick this one right here because I love when something equals to 0, okay? There's my Tn. My Tn is 0. My first term would have to be all the way back up here. It's 100. Okay, so my first term is 100. How many terms did I use? Well, I used the 6th term. So guess what? That's 6 because that's 6. I used T6. That means this is 6 over here. 6 minus 1, there's 5, and there's D. Put the 100 on the other side. That's minus 100 equals to 5d. Divide by 5, divide by 5. Look at that. D, in fact, is negative 20. It is our slope that we figured out right there. There's our slope at minus 20. Oh my goodness, isn't that amazing? Now, can I find out the general term? Of course I can find out the general formula. General formula means Tn equals to T1 plus n minus 1 times d. Well, Tn equals to 100 plus n minus 1. That is, of course, going to be n minus 1 times minus 20. And check this out. Multiply it out and watch how I get exactly the same formula that I had right here. This is the cool part. Watch this. Tn equals to 100 plus a negative 20n plus 20. Combine this, and look what you get. This is the cool part. Tn equals to 120 minus 20n. Or in our case, look at this. Oops, right up here. Minus 20x plus 120, or 120 minus 20x, which is exactly what I had, whoa, way down yonder over there. Look at that. So it doesn't matter how you approach this. You can approach this with a grade 10 attitude and go in here and say, oh yeah, I'm just going to find my intercept and so on and so on. But the most important thing is that guess what? You do not have a y-intercept. So you can determine it from the graph, or better yet, you can use this beautiful formula here, right? Our original formula, T1 plus n minus 1d, to actually give you the right and proper formula. Oh, boy, did I scribe all over this. Now, let's go on to our next part. Let me erase some of this so that we can have a little bit more room. Let's go to T11. Remember, our formula was Tn equals to 120 minus 20 n's. Okay, now we can find T11, no problem, because remember, if you're doing T11, that becomes 11, that becomes 11, right? So T11 is simple. That's 120 minus 20 times 11, okay? So that's 120 minus 220. So guess what? T11 has to be minus 100. Awesome. There's minus 100 for T11. Now, here's some interesting points again. Is the graph considered to be discrete or continuous? Wait a second. What does that mean? What does discrete or continuous mean? Remember, discrete actually refers to points. That means you don't have continuous data. Well, what do you talk about? Continuous means I can draw a line. And what does the line represent? Well, if that's 1 and that's 2, for example, a line represents I can go at any portion in here, right? Anywhere in here and get a value. Well, look at this. Look at this graph. This graph here, let me erase it here so you can see a little bit more of it. Okay? Look at this graph here. The graph is just specifically that point, or specifically that point, or specifically that point. There's no points in between. Why? Because these are terms that are based on whole numbers. So there's no points in between. That, in fact, then, ladies and gentlemen, tells you that it is discrete. It's discrete. There's no line. Okay? So discrete means no line. Okay, and you can't draw a line for this. And of course, the other question was, why is there no intercept? Why is there no y-intercept? Because if you remember, what does a y-intercept mean? A y-intercept means that, guess what? You have to have no terms. We know that's supposed to be there, and if this was going to be a line, we know that this is our y-intercept, but that would mean your n value here would have to be 0. And you can't have a 0 term. There's no such thing as T0. It doesn't work. So some really cool questions in this graphing one that end up being answered. And I think it's just a wonderful question.